Hey everyone! Today, we have an incredible story from the cutting edge of materials science that's sure to blow your mind. Scientists at the U.S. Department of Energy's Brookhaven National Laboratory have used artificial intelligence, AI, to discover 3 new nanostructures, including a first-of-its-kind nanoscale ladder. This groundbreaking research was just published in Science Advances, and we're here to break it down for you. Welcome to Trendstorm. Chapter 1. What they did. The researchers at Brookhaven used a process called self-assembly, where a material's molecules organize themselves into unique patterns. They directed this self-assembly to create new nanostructures that could have huge implications for microelectronics, catalysis, and more. Imagine tiny, intricate patterns that can be used in advanced computer chips or to speed up chemical reactions. Chapter 2. Why it's exciting. One of the newly discovered structures is a nanoscale ladder, something no one had ever seen before. According to Gregory Doerk, a CFN scientist and co-author of the study, these tiny, well-controlled features are essential for pushing the boundaries of technology. By blending different self-assembling materials and using a precise chemical template, the team created these new structures, expanding the potential applications of self-assembly. Chapter 3. The role of AI. Here's where it gets really futuristic. To accelerate their research, the team leveraged an AI algorithm called GPCAM, developed in collaboration with DOE's Lawrence Berkeley National Laboratory. This AI framework can autonomously define and perform all the steps of an experiment. Think of it as having a super smart robot scientist that can make decisions on the fly. Marcus Nowak, a scientist at Berkeley Lab, explained that GPCAM was used ingeniously to explore different features of the model. This autonomous approach allowed the researchers to find the right combination of parameters to create new and useful structures in record time. Chapter 4. How they did it. The team first created a complex sample with a spectrum of properties for analysis. Instead of the traditional method of making and testing one sample at a time, they made a single sample with a gradient of every parameter they were interested in. This single sample was like a treasure trove of potential new structures. They then brought this sample to the National Synchrotron Light Source 2, NSLSE, at Brookhaven, which generates ultra-bright X-rays for studying material structures. The AI algorithm selected the best spots to measure, and within hours, the team had identified 3 key areas for closer study. Using electron microscopy, they uncovered the intricate details of the nanoscale ladder and other novel structures. Chapter 5. Results and implications. From start to finish, this AI-driven experiment took about 6 hours. Traditionally, it would have taken about a month to achieve the same results. Kevin Yeager, CFN group leader and co-author, emphasized that autonomous methods can tremendously accelerate discovery and increase the scope of what can be studied. Chapter 6. Future directions. The team is now applying their autonomous research method to even more challenging material discovery problems. They're also making these methods available to the broader scientific community, which could lead to groundbreaking discoveries in clean energy, microelectronics, and other national priority areas. So what's the conclusion behind all this? This AI-driven approach is a game-changer for materials science, opening up new possibilities and speeding up the pace of discovery. It's like having a supercharged lab assistant that never sleeps and is always getting smarter. Sources: DOE, Brookhaven National Laboratory. Thanks for watching. If you found this video fascinating, make sure to like, comment, and subscribe for more amazing updates from the world of science and technology. Stay curious, and we'll see you in the next video.